Yes, it's starting now.
Who's doing the
We're
intro
starting.
today?
You just did it. Congratulations.
Welcome to Miss Thornhill's stat class. It's super fun.
That was so lame.
Give us points on our quiz.
Correlation does not imply causation.
I'm aware.
That's the intro.
1,358 times you need to write that in order to get +5 on your quiz. All right, so computer output. Let's review computer output and the 4 numbers that we need. So the first one is our y-intercept. It is always next to the word constant. This value has no meaning in the context as it doesn't make sense to have a negative distance. I think we're talking about the rat. We're still kind of talking about that. What kind of rat was it? The mouse rat thing. So, yes, Henry. Deer mouse, yes. The deer mouse, and then how far they travel to find the debris. So it doesn't make sense to have a negative distance. So y-intercept does not make sense. The number below that is next to your x variable, is your slope. The distance traveled to food increases by 3.234 meters for an increase of 1 unit, so 1 meter to the nearest debris pile. We're good with interpretations, yes.
Let's hit up those.
Coefficient of determination, that is our r squared. So only 32% of the variability in y can be explained by the linear relationship between x and y. Then if I were to find the r, so my correlation, what would I do?
Square root of r squared.
Square root of r squared, so square root of 0.32. And would it be a positive or negative r?
Positive.
Positive because? Because slope is positive. Good. This next number, I want you to circle that. This is a new one that we're learning on the PowerPoint, page 95. Yeah, you can't see this.
Yeah. It's like super.
So this S that is to the left is called the standard deviation of the errors, but all you need to call it is standard deviation. It is the typical amount by which an observation deviates from the LSRL. So what I want you to do once you have that, I want you to go to page 99. And I want you to put this S underneath your scripts, like at the bottom. I want you to put S means standard deviation. It's really your standard deviation of your errors or of your residuals. Because think about it, all of your ordered pairs, all of your observations deviate from the LSRL either positively or negatively. So to calculate the standard deviation, it would be your average deviation from the mean. So that's kind of what your standard deviation is. So in this case, our standard deviation is 8.67. That's the typical amount, the typical deviation from which the observation deviates from the LSRL. So remember the script for standard deviation in the last unit was your typical deviation from the mean. This is your typical deviation from your LSRL. So standard deviation has the same meaning, but now it's from the LSRL and not from the mean. This is the formula right here. You do not need to memorize it. However, it is interesting because remember in the last unit we had a denominator that was n minus 1. And what did n minus 1 represent? Degrees of freedom. Right. So the degrees of freedom in this unit, which we don't talk a lot about, but we'll talk more about it second semester, but I think it's fascinating. N minus 2 is the degrees of freedom for this unit. What is the difference between the last unit and this unit in terms of data? Bivariate. Yes. Bivariate. So since we have 2 variables, now we have 2 less degrees of freedom. Like 2 people are not free to vary. But in the last unit, we only had univariate data, so we only had 1 variable. So that's why it's n minus 2 instead of n minus 1 for this unit, because it is bivariate data. So 2 variables, bivariate. But we don't really talk about that until second semester. So I just thought it was a fun fact that I would share.
That was fun.
I know. Okay, so now we're going to learn about when data is not linear. So what I want you to do is put your data into list 1 and list 2. Okay, so your scatter plot should look like this. What do you notice, or is there anything unusual about this set of data? There is one observation that's different from all the rest of them, this point right here. It's influential because what would it do to my LSRL, do you think?
Mess it up.
Mess it up? Do you think it's going to make it stronger, or is it going to make it weaker?
Outliers weakened.
Is it very far from your line of best fit, though, or your LSRL?
No.
No, it's close. It's close to it. So it could strengthen it.
What is this?
Influential observations.
Wait, it's shrinking?
No, I don't know.
No. Influential observations changes your correlation. So influential can be positive or negative. Like it can help your R, like it can strengthen, or it can weaken it.
I graphed it, and if there's nothing in it.
So your influential point, it can either strengthen or weaken your R value, your correlation. So I like to think that influential points can either be good or bad. They can strengthen or they can weaken it. Either way, they're changing your R value. Either it's getting stronger or getting weaker. If I removed this point, that would change my line completely. So a point is considered to be influential because it affects the placement of your LSRL. So this observation right here has the largest residual. That's called an outlier. So I like to think about outliers as always being bad. Like they are always negative, largest residual. So there's only one. There's only one outlier. And it is the furthest away from your LSRL.
Wait, are you talking about there's always only one outlier, or there's... Oh, okay.
So you could have multiple influential points, but there's only one observation that has the largest residual. So there's only one outlier. Unlike when we did the box plots, you could have several outliers. There's only going to be one that is an outlier. And outliers are always bad. Influential points can be good or bad. So that's kind of the main thing that I want you to get from this. So when you graph this data, you'll notice that it appears to be kind of curved. It appears to be curved, but how do we check whether the linear model is appropriate or not? How do we do that? We need to check the residual graph. So I want you to graph the residual. Go ahead and graph the residual plot.
Second, why?
When you're making a residual plot, you go to stat, calc, 8 first, because when you create a new set of data, you need to find your LSRL first. Okay, when you do that, you're getting a new set of residuals, and then it's storing those residuals in your calculator. So once you've done stat calc 8, you're going to go back to second, y equals. You're going to change your type, your y list. So my y list is going to be second stat 7.
I got center B. Second stat 7?
If it's not 7, then it's 8. It should say residual. So second stat residual.
Second.
Then hit zoom 9. My residual plot looks like this. So if I were drawing this on a free response, I would put resid.
Whoa.
I would put resid on this side. My x is number of days after injection. So number of days after injection. And then my scatter or my residual plot looks something like this. So would you say that there is a pattern?
Yes.
Yes. So since there is a pattern in the residual plot, the linear model is not appropriate. So we're going to learn how to transform our data. If your residual plot is patterned, that means that you should not use an LSRL. You should not use the y hat equals a plus bx to predict. So there are different functions that we're going to learn, and there are there's a suggested list in which you go through in order to get a residual plot that is not patterned. So if there's no transformation, your residual plot is scattered, then you're good. The next one that you try could be the square root of y, could be log y, log x, 1 over y, and just log of y. So these are all options of different ones, different transformations that you can try. Okay, you don't have to memorize this list, but you should know different options. But the order that we typically go in when we're doing these is you calculate your LSRL. If it's scattered, then we try these options. This list 1 through 4 are really the only ones that I've ever seen on an AP test. And I suggest going in this order. So what I would do is on this slide, I would circle that and say use this order. So what we can try now is using or making a scatter plot with x and log y. Then if that doesn't work, log x, log y, x and square root of y, x and 1 over y. These are the most common transformations that I've seen. So what your steps will be is you transform your data, you find a new LSRL using that. So you'll create a new LSRL with log of y hat and a plus bx. Then you will draw a residual plot for those two sets of data. If your residual is then scattered, then you're done. If it still has a pattern, then you go to the next one and you try log x and log y. Then if there's a pattern again, you go to log x and square root of y. So you're just testing them out and seeing. You're going to keep going until you get a residual plot that is not scattered, or that is not patterned, that is scattered. So here's the little effects. It means you keep trying, trial and error, until you get a residual that is scattered. So you want to keep trying until you get a residual that is scattered. So since this data seems to be exponential, let's try x and log y. So what you need to do in your calculator, you're going to go to L3. You're going to highlight it. So stat edit, go to L3, highlight it, and type in log of y, which is your L2. So second log of L2. So you're going to go to your L1 or your L3. You're going to go up, hit enter to where you get the blinky square. Then you're going to type in log of L2. That means that's the same thing as getting my log of my y values. Log is the button under x squared.
So you go stat to what?
Stat edit. Go to L3.
Oh.
Well, we don't.
And you should get numbers like my first one is 1.6021. My second one is 1.8751. Things like that.
What does the log y mean? We put that in there?
So once you get log of L2, you're going to go to stat calc 8. So stat calc 8 is going to be L1 and L3 now. So stat calc 8, change your y list to be L3. And to get L3, you hit second and then 3. Then hit calculate. So you're changing your y list to be L3 now. When you do stat calc 8, my x list is still L1, and my y list will be L3 now. If you looked at the scatter plot, it would look something like this. Does this look a little bit more linear?
Yeah.
No.
Yes, it does. This is now the transformed. So my x-axis is still x, but now my y-axis is log of y. So I changed my x to be L1, my y to be L3.
So does that mean that you...
The LSRL would be this.
I see no pattern.
Ours looks funky.
Oh, that's because you still have it on residual. So if you want to go back to scatter plot, change it to L1 and L3. Is that your residual?
Oh.
So this is just my scatter plot right here. This is just my scatter plot. I would write my I would write my LSRL like this. So you are now writing it as log of y hat equals a plus bx.
So you're just trying to get it to where it's an appropriate graph?
Yes.
Wait, how do you know if it's appropriate?
So how do I know that it's appropriate? That's a great question.
Oh, you do the whole
I
thing again.
need to now go back into my second y equals, and I want to graph the residual plot.
That's what I'm what we just did.
So my residual,
Oh my.
I'm going to go to second y equals, and I'm going to change my y list to be resid.
Do that again. It's stat list.
And my residual looks
It
something.
looks like a mountain.
No,
It looks pretty scattered to me.
Like a mountain.
what's going on? Now give it to me.
This is a mountain. Then do
We
write
transformed
out?
it to x and log y. I have to go back and check my residual to make sure it is scattered. When you create your new list, L1 and L3, you do stat calc 8, and you get a log, or an x and a log y formula, your LSRL. And it was log y hat equals 1.226 plus something x.
So then we write the new equation.
So that is my new equation. And then I go back into my scatter plot and I want to check the residual to make sure that it works. If my residual is scattered, which it is, if you look at the picture on the board, it is scattered, then I'm good to go. If it were not scattered, then I would have to try again and I would have to do another transformation. So then I would want to do log x and log y. Or I could do x and the square root of y. Or I could do x and 1 over y. You can just try these different transformations until you get to where a residual is scattered. I will say there's not always one right or wrong answer. So you could do one transformation and then the person next to you could do another transformation and you end up getting 2 scattered residuals and they both work. So sometimes more than one transformation will work. So it just depends on which one you want to prefer to do. I personally like to go in order because I am very much of an order type person. I want to start with x and log y, then I want to do log x, log y, and I want to do x and the square root of y. And I want to go in that order because it's something that can, instead of just trying different ones, it gives me an order to go in. And normally you'll get it by the time you try the second or third one. So then you might also get questions, I've seen these a lot on multiple choice, where they give you a transformed equation, and they say, what would the predicted average tumor size be 30 days after injection? So I'm going to plug in 30, and you're going to get an answer, but you will not say that y hat equals whatever you get for 1.226 plus 0.041 times 30. You have to actually remember your algebraic skills, and you have to solve for y hat. So how can I get rid of, or like what is the inverse of having a log function on the left? 10 to the power. So I would say y hat equals 10 to the power of 2.456. An easy way to, instead of like trying to memorize all of these, is that if you hit on your calculator second log, it's the opposite. It's 10 to the power. If you hit second x squared, then it does a square root function. It does the inverse. If you hit second natural log, it does e to the power. So if you hit second and then that function, it's actually the inverse of that function. So
when will we use the natural log?
you might see it. I don't really suggest that y'all do natural log transformations, but you might see one where it's given to you as a natural log.
What is natural log?
ln.
Which is like, what is it? E equals?
It's the base. It's like a log with a base 10. Or base e, sorry. Base e. And then log is just a base 10. So you end up getting 285.76. So make sure if you're given a transformation or if you transform that you always transform it back to solve for y hat. So you want to make sure, oh goodness. You want to make sure that you solve for y hat using your algebraic knowledge. You're on. Yes. Okay, one last thing that I didn't mention. One last thing that I did not mention that is really, 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 really important, and this was also on The quiz, that's the one that I omitted. So let's say that you transform your data and you get, so we had x and log y. That was our transformed equation right here. So we have x and log y. And here's my residual for x and log y. And then I said comment on this residual plot. So my comment for residual plots is always since there is no pattern in or on the residual plot, a linear model is appropriate for the relationship between x and log y. So there's not a linear relationship between x and y, but there is a linear relationship between x and log y. So make sure that when you write this sentence that you include the transformed function. So I don't have a relationship between x and y, but I do have a relationship between x and log y. So I think on the quiz, if y'all look at that number 7, it says, suppose that the scatter plot of log x and log y shows a strong positive correlation close to 1 and appears linear. Which of the following statements is true? Then you would say that the residual plot of log x and log y will show a nonlinear pattern. So the answer would be D.
Oh.
So you would not, anything with the variables x and y would be automatically omitted. Okay. So you're now talking about log x and log y. Okay, so everyone has this in their list 1 and their list 2.
It's linear.
It's linear.
Let the rest of us get there.
Hold on.
Let's do it.
What do you mean it's linear?
I don't know. I have no idea. I haven't done this. So I'm going to go to Stat Calc 8. And I'm going to type in list 1 and list 2. Oh, I have no idea. So, nope, I don't want to use the highlighter. I would like to use this. So when I find my line, my LSRL, it is y hat equals 1.864 plus 0.0178.
I didn't get that.
I got something different.
I got 1.5.
I got the same.
Yeah, 1.5.
You got, I'm wrong?
You're wrong.
Okay, let me try this. Okay, I had it wrong, but now it's right. So we're good to go. All right, so once you calculate that, my next step to tell whether it's linear or not is I'm going to try and graph the residual. So I'm going to go to second y equals. I think that everything is good, so you don't necessarily have to go to second y equals. You can just keep hitting zoom 9 because everything's already there. So my zoom 9, I've got residual here.
Does it look like a hump?
It looks something like this.
These are strange.
Is that what your residual looks like?
Yes.
That's okay.
That's exactly what
And what is my x variable? Like mammal weight or something like that? Mammal something.
How do you know what X and Y is?
Whatever your list one
Is
is.
that a pattern?
Is that how you spell mammal?
Probably not.
M-A-M-M-A-L-E-L?
Yeah.
Oh, that looks weird.
Is that a mammal?
Mammal.
Mammal?
Okay, is this a pattern?
Yes.
Yes, it's patterned.
It's a hump.
Therefore, we can stop there. Right?
Patterned. So, no good. So what's my next step? I'm going to try
Log the Y.
x and we're going to log the y.
What? How do we do that again?
That is patterned.
Edit.
If I want to do x and log y, because that's my next step, I'm going to go back to stat edit. So stat edit.
Log of L1.
Edit. L3.
Then L3, I'm going to highlight it. If you already have stuff in there, if you highlight L3, hit the clear button and then hit the down button. It's going to clear out your list.
This looks like a hyperbole.
These are some weird numbers.
Okay.
So x and log y, my first entry is negative 0.2596.
Where?
They don't fly.
Excuse me. Wait, but so no, what's that number?
Negative 0.2596. That was my first entry for L3.
That's not what
It doesn't work.
So when you go to stat
I got
calc
that.
8, do you have to change the
To L3.
So then I go to stat calc 8, and I'm going to change my Y list to L3 now. Hit calculate,
and then you get
and it would be log of Y hat equals 0.1582.
Hold on.
Is this what y'all are getting?
I have 0.63.
Yes.
I got what you got, Miss Thornhill.
Okay,
Wait,
y'all have me
why
second
are we
guessing
already writing it before we check to make sure if it works?
because I just want to make sure everyone's doing it correctly.
Because
That's
better
enough.
write it or thinking of it.
Yeah, it doesn't work.
Okay, let's look at the residual. So I'm going to hit zoom 9.
It's pattern.
That's a,
Look at
Is it
that.
really?
That's
that's a
We're gonna need to log the X.
We're going to need to log the X. So zoom 9. I end up getting a residual that looks very similar.
So it's saying it's the exact same.
It does.
Yeah.
So we put on L4, we go log of
What if it's
L1.
So my residual is still patterned. So it is no good.
It's non-linear.
So now I'm going to try log X and log Y. So here's what my suggestion is.
That one doesn't work either.
Freaking
Mm. We're going to take it a step at a time. So just bear with me. So what I do is I go to L4 and I make sure that I write underneath log Y L3. So I keep them like I write the list next to it so that I know what I'm doing. Otherwise I get confused. So I'm going to go to L4 and I'm going to type in L4. It's going to be the log of L1. It's going to be the log of L1. And that's giving me all of my log of X's. Then when I go to stat calc 8, I'm going to put my list 4 as my X list and list 3 as my Y list. I know that seems backwards, but my log of X's are in my list 4.
Wait, maybe it does work. List 3 is list 4.
Yes, because this is my log of X's, is my list 4.
What's this for?
Log of X's.
Is that right?
And my L3 is my log of Y's.
So we just do log X.
Why couldn't we do log X first?
You could if you wanted.
So you log X.
So my log X's I put in L4. If you want to do it different than me, that's fine. As long as you're keeping track of where your log X's are and your log Y's.
I think it works actually.
So then my linear, my LSRL would be, it should be log of Y hat equals negative 0.0124 plus log of 0.3652. Okay, everyone look and see what I did. Look. I have log X and I have log Y, so I'm going to have 2 logs in my equation. Does that make sense? Yes, now I need to check my residual, so I'm going to hit zoom 9.
Is it still L1 residual?
However, listen. Listen. However, this is so important. Whenever you go to your scatter plot or you want to find the residual, I am now going to graph it on. I have my residuals here, but instead of it being L1, your X's, it's going to be the log of X's. Okay? And what list is my log of X? L4. So it's going to be my X list is L4. My Y list is resid. Okay?
Oh, because we didn't change the X file.
Yeah, it still has a pattern.
It's a pattern.
It's a pattern. I like to choose the hardest examples with you so that I can guide you along so that when you do the homework, it's going to be easy.
Oh yeah, I'm so confused on what you determine a pattern.
Alright. Can we clear
That's
list
what mine
3 and
looks
list
like.
4 now?
Is this
Yes. Yeah, that's what mine looks
How is
like.
this a pattern?
Wait, yours looks like interesting. Wait, her.
That's what
How
that
do I have?
Wait, you said yours looks like mine.
This is what mine looks like.
How is that a pattern?
Mine looks like the one that's on the board.